Hello, welcome back. So in this video, we are going to go through the fundamental theorem of algebra. What this means is it is the way to find all the roots of a polynomial. All right. Now, the way that this works is I'd let you choose, or I'll let you use a graphing calculator to find the zeros. All right. To find any that you can actually see. So, what I mean by that is whip out your graphing calculator, please. You're going to put that polynomial in your calculator. So, x cubed minus x squared plus 4x minus 4. All right, so I put that in my calculator, and I see that there is a real solution, okay? There is a 0, and that 0 is right here. All right, now, it looks like it's at x equals 1. But let's go and check to make sure that it's 0 at x equals 1. So I'm going to calculate. So I'm going to go into the calculate menu I've shown you before. And I'm going to calculate the value. Okay, so that first option right there, I'm going to calculate the value. I want to know the value at 1. It is actually 0. See that y equals 0? So it's telling me that I was right. That x equals 1 is my first solution. It is one of the zeros. So what I'm going to do, because I've identified that it's one of the zeros, I'm going to synthetically divide it out. So over here, I'm going to keep track. So x equals 1 is a 0. 1x cubed minus 1x squared plus 4x minus 4. Once I've identified one of the zeros, I'm going to use synthetic division on it. I'm going to pull down the 1 and multiply. Add, then multiply. Add, then multiply, add, and we're done. Okay? So, now let's see what I've got. After I synthetically divided the 1 out, I have a remainder of 0, constant of 4, no x's, and an x squared. So when I synthetically divided that out, I ended up with an x squared plus 4. So I end up with a quadratic. Now again, I'm searching for zeros. I'm searching for solutions. So now that polynomial that I have left, after I've taken out the first solution, now I want to see where does that equal 0? Okay, because quadratics I know how to solve. So again, I pulled out the first solution. Now the polynomial that's left, I want to see where this is 0. Subtract 4, square root both sides. Well, square root of negative 4. Remember, when you square root in an equation, you get plus or minus. Negative 4, don't forget the I because you're square rooting a negative. So I have a solution of 1 and a solution of plus and minus 2i. Now, I want you to think about that, plus and minus. So really, that is 3 solutions. And 3 is a number that I should have been getting based on the fundamental theorem of algebra. It tells me I should be getting 3, and using synthetic division, I've actually found all of them. Pull out the one you see with a calculator, and then whatever you have left, you can solve. All right, let's take a look at another example of this. So I'm going to type that into my calculator now to see what 0 I can see. All right, so go back to graph, or to y equals x cubed plus 5x squared minus 3x minus 15. And I'm going to graph it. All right, so here I see it crossing in 3 places. Okay, however, I want you to notice this is the only one that it appears to be crossing at a nice value. Okay, so that's going to be the one that I want to focus on, the one where it looks like it's crossing at a nice value. And to me, that looks like -5 is where it's crossing. Now, it's always a good idea when you're looking for zeros, calculate that value to check that that actually is a 0. So I check -5, and yes, it does say y is 0 at that point. So -5 is my first solution. Now that I have that as one of my solutions, now I'm going to use synthetic division to pull that solution out, and I can solve what's left of it. 1x cubed plus 5x squared minus 3x's minus 15. Pull down the 1, multiply, add, multiply, add, multiply, add. Right? And that's what I'm going to get. So I have a remainder of 0, constant of -3, no x's, but I do have an x squared. So that polynomial is going to be an x squared with a constant of -3. But I want you to remember, -5, we already know is a solution. Now my other two solutions are going to come from that polynomial that's left after I synthetically divide that out. All right, so I'm going to set this equal to 0 because we're trying to find the zeros, and I'm going to solve it. I'm going to add the 3 over, square root, and remember square rooting gives me a plus and minus, and that is going to be what my other two solutions look like. All right, and again, you know you have all 3 because a plus and minus makes 2 of them. We started with a -5, and because this is a cubic, that's telling me that I had originally been looking for 3 solutions, and now I have all 3. All right, so that's what the fundamental theorem of algebra lets us do. Now we are going to have another notes to practice this a little bit more, but I do want to give you time to practice it now. So, as always, make sure you have everything written down, all of my work, and then come ask me if you have any questions, please.